Hello and welcome back to Penrose From Scratch. This time we're taking a look at hooks. So last episode we had a look at key bindings. That's one of the main ways that you're going to run custom stuff in your window manager. You're going to get some code, bind it to a key, hit that key, run that code. The other thing you can do is set up hooks. So that's more driven by the window manager. So when certain things happen in normal execution of the window manager program, you've registered some code that should get picked up, which is quite nice. It means that you can kind of respond in a kind of an event-driven kind of way. Now, Penrose offers a couple of different places where you can do that, and the docs are the best place to have a look at how this all works. Now, earlier this year, I did a kind of rewrite of the internal APIs of Penrose and a redesign. That went from 0.2 to 0.3, and in doing that, I went through and rewrote a bunch of the docs, but there's some stuff that got missed, I've been realizing, now that I'm doing this video series. So as I go through, I'm filling in the blanks. So if you spot anything else that you want to be making use of, but the docs are pretty bare bones at the moment, please raise an issue in GitHub, and I'll see about getting that filled in while we do this series. But yeah, so if you go to the link for the current developed docs, so that's this one here, and you click this link here, then that will take you to the most up-to-date version of the docs that I'm working on at the moment. I'll push a new point version of Penrose once we get a bit further on in this series, rather than just constantly pushing new point versions with tiny fixes. But if you go to Penrose Core Hooks, or just in the search bar up here, you type in hooks, it'll show up. That will give you a little bit of an overview on what hooks are available with Penrose. Now, there's 5 points you can kind of hook in. So we'll have a quick run through those, and then I've got a little kind of diagram set up to kind of show you what the main kind of window manager event loop looks like. We won't go in huge amount of detail, but we'll kind of have a quick kind of overview of the kind of life cycle of what's going on as your window manager runs. And we'll see how that works. So first point is startup hooks. Probably felt self-explanatory where that runs on startup, but there's a it's good to know exactly where in the startup process it runs, so you know kind of what you can and can't do. Not too complicated, but you want to know exactly what's run before your startup hook and what's running after your startup hook. Event hooks are kind of one of kind of a pair of hook points where they're going to fire every single time anything kind of runs through the main window manager logic. So event hooks run when the X server sends events through to Penrose, and you get to look at the events before Penrose handles them. So you get to have a look, run your own logic in response to them, and also, very importantly, you get to decide whether the default handling that Penrose would run is going to take place or not. So unless you've got a really good reason not to, I'd always advise that you run your event handling logic and then run Penrose's afterwards. So that's just returning true from your event hook, your kind of flag on whether that should run or not. If you're doing something like taking ownership of a window that's just been spawned, or you're wanting to modify the way that certain X events are handled, and you really know what you're doing with that, if you return false, you can disable the default handling. But if you do that all over the place, you are going to run into problems because the rest of the window manager logic just isn't going to run. So be careful with that. But it is very useful in a couple of places if you know what you're doing with it. Next up after that is manage hooks. Basically, anytime a new window opens or a new program starts, a manage hook is run to see if you want to do anything with the sort of internal pure state before we map it to the screen. So common stuff for that is things like pin a program on a certain workspace, or make it floating and positioned in a certain place in the screen. But really, you can do pretty much anything you want. This one runs kind of after we've kind of pre-processed everything. So we've got the internal state ready. We're about to kind of say, cool, let's go re-render. But just before we do, we call your manage hook and we see if there's anything you want to do first. There's a lot we can do with that. We'll do a sort of simple example. I think we're just going to make my browser render on workspace 5 rather than 3, so we can show you that it hops over. There's then, I should reorder this actually. Layout hooks should go before refresh hooks. I'll shuffle this round and push a change for that. So layout hooks, as you might imagine, run when you lay out the windows. It's kind of self-explanatory. This one's a little bit different though. All the other ones, so startup hooks, event hooks, manage hooks, refresh hooks, which we'll look at in a sec, they are all just one function. They're kind of one bit of code, which is kind of cool. The window manager is doing something. I'm going to defer to your hook, and you can do whatever you need. And then we'll go back to window manager execution. Layout hooks are kind of their own kind of bookend kind of thing, because they can do two pieces. They can modify what a layout algorithm will see before it lays out the windows. And then once the layout algorithm has said where all the windows should be positioned, it can mess around with those positions. So you can kind of do, you can kind of in and out of the layout algorithm, you can mess with stuff rather than just before or just after. So those ones are a little bit of a special case. We'll have a look at those, and we're going to add a layout hook to tidy up the way that our status bar is rendering. So at the moment, if you think back to episode 2, we use something called a layout transformer. So we had this, we mapped reserve top, and that's what's going to making sure there's a bit of space at the top of the screen for our status bar. That works. Layout transformers are super powerful and really useful and really, really kind of dynamic. They're a really kind of rich way of modifying the way the layouts work. But actually, if we just want to always have space for the status bar, or some nice gaps around our windows is the other thing we're going to add, then a layout hook is a nicer way of making sure that just always runs for absolutely everything. And that's something which I've only just recently added, which is why we didn't do that last time. I actually realized this when we did this last time and thought I should just have a layout hook. So Penrose now has layout hooks, which is all good. But yeah, last bit is a refresh hook. And that's kind of the companion to the event hook. We'll have a look at that in a sec. So an event hook runs when an event comes in before Penrose handles it, and a refresh hook runs anytime that Penrose has updated things on the screen. So if an event came in and nothing modified, then your refresh hook won't fire. But anytime that something changes about the internal state, so if the number of screens has changed, if the workspaces that are visible has changed, if the windows have moved around, if focus has changed, and all of those things trigger a refresh. Anytime your refresh runs, that is the last thing that happens in the event loop before we loop back up to the top and start again. So speaking of that event loop, I have a diagram, yay, which is kind of going through how the main event loop for Penrose works, which is this. This is the main event loop for Penrose. It's pretty small. And this is kind of taking a peek inside what some of these kind of downstream functions are doing. But this is kind of window manager execution once you call window manager.run. So if you remember, that's kind of the last thing we do in our main RS. We set up our logging, we go set up our status bar, our connection to the X server, we add whatever hooks we want, layouts, we do all our config, all our setup, and we make our window manager, and the last thing we do is we call window manager.run. And I said in a previous episode, that's just an infinite loop. And this is that infinite loop. That's it. That's all we do. There's a little bit of pre-processing, so startup stuff that happens, and this is where your startup hook runs. So the very first thing that happens is you register something called a signal handler. If you're really interested in signal handler stuff, go you. But it's kind of a bit of an arcane kind of topic in terms of the way that Unix works with child processes and, well, not just child processes, processes in general. We're not going to go into it. It's kind of very arcane and cryptic. It's not something that you need to know about. It's also the only place in the entire Penrose code base currently where I have to use unsafe code. That's because I need to call an external C function. or a wrapper for an external C function to sort of set that signal handler. The sort of TLDR on this is literally just when you have key bindings for spawning programs, so opening up your terminal, opening up your browser, whatever it is you're doing, this makes sure that those behave correctly when they exit and when Penrose exits. That's kind of it. So we'll move on from that. After that, we grab your bindings. So this handle mapping notify, we'll have a look at why it's called that rather than just grab bindings in a sec. But yeah, we'll grab your key bindings and mouse bindings. Penrose technically supports mouse input. It's very, very minimal at the moment, so I've not really kind of got much around it. I really need to extend the mouse input stuff at some point soon. So we'll have a look at that in the future. But yeah, this is where we kind of, for anything that you had in your config, so all the stuff that we've been doing around setting up key bindings, and we say, hey, look, here's our key bindings. This is what we want all our shortcuts to be when we're running Penrose. This is where we tell the X server we're taking ownership of those key bindings. That doesn't cause the code to run, but as we'll see in a moment in the main event handling, that just means that any time one of those key bindings gets hit, we get notified about it, and we can then look up the code that we need to run. Once you grab the key bindings, that's when your startup hook runs. So we've set the signal handler, so child processes, so any spawned programs that we got are going to behave properly. We grab all the key bindings, so we know that we're listening for those key bindings, and then we run your startup hook. Now, a very important thing for all the hooks in Penrose is this may or may not jump out at you, depending on how much you have worked with programs like this or are a software engineer in general. There's no threads here. Penrose is single-threaded. That's largely just to kind of keep the complexity down. But what it means is your hook code runs in a blocking way inside of the main event loop. So if you have a hook that kind of decides that it wants to run an infinite loop, Penrose is just going to deadlock because your hook's running, it will never get back to the main window manager event loop. We will stop processing events. So if you want to run anything asynchronously or off to one side, you need to spawn a thread for it. But rather than Penrose sit there spawning threads left, right, and center and doing all sorts of bits and pieces, or bringing in like Tokyo, like bringing in an async runtime, first and foremost, I wanted to see how far I could get with a super simple single-threaded event loop and really keep Penrose tiny, tiny, and minimal. It doesn't really want to take up too much resources on your machine. So that's just one thing to be careful of. Your hooks need to not block the event loop. So don't do any long-running things in there because your window manager is going to kind of hang and stop responding to input while that code runs. But this is where your startup hook runs. After that, we manage existing clients. So that's the kind of stuff where when we restart Penrose using our little dmenu helper that we wrote last time, this is how Penrose is able to then, when it starts up again, find all the windows we had before and put them in the right place. It's kind of a kind of throw everything up in the air and catch it kind of situation. We have to kind of go and find all of the programs that are running and put them back into state. Because Penrose has just started completely fresh, it doesn't know what it was doing before. But once we've done that, then we can. My mouse is disconnecting and connecting. Once we've done that, then we're into the main event loop. So the main event loop really is pretty dumb and simple. We get an event from the X connection and we handle it. That's kind of it. This sort of span and enter and bits and pieces stuff is just some stuff to help with details around logging, so you can kind of track where things happened. And if you have a look here, this isn't something we've mentioned, but on the state that you have access to inside of your key bindings and your hooks, we can actually stash the event that we're currently processing. So anytime your code's running, you can have a peek at that and you can see what event is currently being processed, if that's useful to you. And yeah, that's kind of the event loop. So that's where we get down to here. And we're into handle next event. This is then kind of that loop that we're going around. So inside of handle X event, there's a couple things that are happening. So the first thing is your event hook runs. So again, window manager is going to essentially stop doing its stuff. It's going to run your code instead. And you get to make a choice with this. That's something we mentioned earlier. You get to decide if the default handling should run or not. If you're not sure, the default handling should run. You should only disable the default handling if you really need it to not run. And if you're going to disable it, I'd really highly suggest you come to this handle X event function in the window manager. So that's just in source core modRS. And have a look at the handling functions for the events that you are wanting to take ownership of. So all of those are in handle RS. So source core handle RS. Each of these is just a function that is the name of the event that it is handling. So if you come to this file, have a look. This will tell you what the default handling behavior is. Make sure you really want to turn that off before you have your event hook return false. If you really want to turn it off, that's fine. Penrose will try and make forward progress. It will try and do stuff. But if you've started dropping events that we really need for tracking what's going on with the state of your desktop, you're going to end up having a bad time. So be careful with that one, but it is very useful if you need it. So assuming that your event hook hasn't said we should skip the default handling, we actually drop in and have a look at handling the event. And like I said, each type of event that can come through from the X server has a corresponding handler. Or rather, most of them do. There's some events that come through from the X server that Penrose doesn't currently handle. It might handle in the future. It depends on what kinds of stuff we want to work with. But if you want to handle them, you can. So that's why they're still in there as an event type rather than just not being there at all. And depending on the event, different things are going to happen. This is where all the kind of business logic in Penrose then lives. Most of the handlers aren't that big. They're fairly simple kind of call and response kind of things to each event that comes through. But there's one that is special, which is this one, map request. So map request is what happens when a new program has been opened and wants to be drawn onto the screen. It basically tells the X server, hey, please map me to the screen. So we check to make sure this is something that we should be managing under the window manager. So for example, like the status bar is not something to be managed by the window manager. We're not tiling your status bar. There's ways for client programs to tell the window manager, hey, leave me alone, I know what I'm doing. But assuming it is something that we need to manage, we will call this manage method on the X connection. And that will then do all the kind of pre-processing and bits and pieces that we need to do to work out how we put that into the window manager state. The last thing we do before we actually then pull that in and render everything to the screen is we call your manage hook. So we kind of get everything in place, we set the state up the way that we think we need to in the default way, and then your hook gets to run and we tell you the ID of the window that we've just managed. So if you want, you can look it up and you can do things with it and you can kind of see what's going on. Provided that's all fine, and your hook doesn't kind of hang the window manager or anything, so again, be careful with blocking code, we will end up triggering a refresh. And for most of the other event types, those also trigger a refresh. There's some things that don't, but very few of them. Most of them are going to trigger a refresh. So like enter and leave are when your cursor moves from one window to another. So if you look, the red border is around the terminal. Now it's around the image viewer. Terminal, image viewer. And the thing that's driving that is the enter and leave events coming from the X server. So that event's coming through, we're changing which window has focus. The focus window gets a different colored border around it. So we settle that and we render that state out. But anytime that refresh hook happens, we need to check to see if the windows are in the correct position. So we will run your layout hook. That will then do that kind of pre and post processing around the layout algorithm that we mentioned earlier. And that will give us all of our window positions. Those are used as part of updating the X state. That's part of what we need to do. We need to tell every window where it needs to be positioned. And then at the very end of that, we run this refresh hook. So if we have a quick drill down into that, you'll see where that works. So I think we looked at this last time when we looked at the modify and refresh, which was down here. So we run your code that modifies the window manager. That's what all these kind of handlers are doing. They're doing something that modifies the window manager. We then compute that diff, and then this is where we're kind of doing all of the X server stuff. That self.position clients is where we're actually setting all the client positions. But this position and snapshot up here is where we actually work that stuff out. So this is where we call your layouts. And yeah, if we have a hook, we'll transform the initial screen real estate that you've got available using your layout hook. We then lay out the workspace. And then once we've laid out the workspace, we then run it through the post-processing of your layout hook and say, cool, here's what the layout gave us. Do you want to change anything? But then after we've done that, we've then got our positions that we can use for updating everything, and then we can run your refresh hook. So that refresh hook, if you have a look at the way this is set up, really is just we've done everything else before we return. If you have a refresh hook, we will run it. So the thing to remember with that is that that's run after we've updated the X state. So you can't use a refresh hook to kind of prevent stuff being rendered out to the screen, but you can kind of see what just got changed. And then after that, that's usually the last thing that will happen as part of responding to any incoming X event, and we'll be finished processing that event, which means that we exit handle X event, which means we go around the loop again and we look at the next X event. That's kind of it. So there's obviously a ton of detail I've glossed over there, but that's kind of the life cycle of what's going on. So for our purposes, we're going to go and implement a couple of these hooks. Some of them are a little bit esoteric to kind of implement in a, hey, here's a simple example to show how the hook works. Because it's kind of, there's not much you can do. Like with an event hook and a refresh hook, those ones that kind of bookend, you're really kind of doing that if you want to kind of track and modify external state with stuff. So I think we'll leave those fully for when we have a look at how the status bar works or how like named scratch pads work. They use those hooks because they need to kind of keep track of the ongoing behavior of the window manager and kind of do things because they're kind of keeping track of some extra stuff off to the side. So they kind of need to update their internal state in response to that. But a startup hook, a manage hook, and a layout hook are three things that we can quickly add to our window manager to wrap up and give us a little bit of extra behavior, which is nice. So let's have a look at a startup hook to begin with. We'll spawn that helper script. I think that's what we'll do. So if we remember in scripts, in the Penrose From Scratch repo, we've got this Penrose startup script. You will want your own startup script, most likely, and you want to make sure that all the programs you're running are things that you actually have installed. For me, this is kind of setting up compositor, power management, screensaver, that kind of stuff. But you can put pretty much anything you want in here. And then we'll make sure that we run this when Penrose starts. So for getting that to work, we're going to add a startup hook that's called spawn on startup. Now, I know where these things are. Mostly, I forget usually the imports, but I can find them very quickly. But a good way of exploring the code base is to have a look through the documentation because it will link off to what implements those different traits, which is very useful. So if you want to know things that are kind of provided for you that have that kind of functionality or something you can use as a reference, this is how we're going to find it. So startup hooks use a trait called state hook. So we're going to click on state hook. The only method you need to implement for state hook is this call method. This kind of then boxed and then boxed are kind of helpers for composing hooks together. We'll maybe take a look at that later once we end up with more complicated setups further down the line. But for now, all you need is call, and you can double check that in the docs. It tells you required methods and provided methods. So provided methods are things that if you tell me how call works, I can then implement these ones for you. You can override it if you really want to, but most of the time you just leave the provided methods as is. You just need to implement the required method. So there's only one required method. But if we scroll down, we are looking for implementers. And this will show you in this crate, so inside of Penrose, what implements this trait? Now, that composed state hook is just a kind of helper thing that you get once you start chaining these things together. But the two that we care about are spawn on startup or notify state. Now, notify state is kind of a debug utility. It will use your system notification system. I use Dunst, I think is the one I use, for just like popping up a little window with some information. This is just a way of kind of popping up like a string representation of what the internal state currently looks like. It kind of is just a helper I've got for running if weird stuff is happening and I want to kind of see a little notification of how things are changing as I'm running. But spawn on startup is the thing that we care about. And this one, you just literally say boxed and you provide the program. We're going to gloss over what the heck this is at the moment. This is a fancy type thing that lets us be efficient about storing the name of your program. We can just put a string in there. So we're just going to put a string in there. But if you have a look, this is in Penrose extensions, hooks, startup, spawn on startup. So that's what we're importing, rather, not implementing. So Penrose extensions, hooks. So it's next to the EWH ones. And we want startup and spawn on startup. And I'm going to kill that other session so that we're not hanging things. No, Rust Analyzer's got very sad for some reason. Oh, Rust Analyzer. I don't know if anyone else gets this. I sometimes get Rust Analyzer will just hang on me, which is very annoying. So we'll have a look at spawn on startup while that works out what it's doing. And we'll come down here. So hooks are all added to your config. So we're going to set up our hooks ahead of building our config struct, and then we'll drop them in. So this one, we're going to put it into user local scripts. That's where we're putting this as part of our makefile, and we're going to have Penrose startup. And then when we come down to our config, we're going to say startup hook, and we're going to say some startup hook. I say this reasonably often just because I'm never sure if people watching this are already experienced with Rust or if this is the first time you've ever looked at Rust. Some is how we specify that we have some optional data available. So there's a type in Rust called option. It's got it's an enum, so it's got two variants, which are some and none. Some means that you have something there, none means you don't. And this is kind of Rust and functional programming type languages response to null. So rather than everything being nullable and you could just have a null pointer exception, or you thought you had a type, you thought you had a string or an int or a struct or whatever it is, and it's just not there. For Rust, it's in the type system. So if it's possible for something to be missing, you need to say that you either have something or you have nothing. So rather than the default, which is we have no startup hook would be none, we've got some startup hook because we've just added a startup hook. And then the other thing we're going to quickly add is a layout hook. Now, for that one, we'll do the same thing. So we'll go back to the hooks and we'll find layout hook. So layout hook, like I said before, is a bit special. It's got its own trait and it's got two methods, transform initial and transform positions. So we'll do the same thing. We'll scroll down to implementers, and there is this thing down here, spacing hook. Now this allows us to provide general spacing for a couple of different things. So we can reserve space at the top of the screen, reserve space at the bottom of the screen, and we can provide gaps. And if you've worked with tiling window managers and gaps before, you might be familiar with this concept of inner and outer gaps. Inner gaps are kind of gaps between windows when they are tiled. Outer gaps are gaps between the edge of the screen and whichever windows are next to that. And generally, you use that to make sure you've got a consistent width between the edge of the screen and the ones inside. Because if you've got a gap of, say, 5 pixels, that's what we're going to go for, you'll have 5 pixels outside this window and 5 pixels outside this window, which means that in the middle, you've actually got 10 pixels. but on the edge of the screen, you'll only have 5. So this is kind of a way of kind of basically putting a gap around the screen itself. So we'll have this one. This is in built-in hooks spacing hook. So we've got built-in hooks spacing hook. Rust Analyzer seems really sad. Why is Rust Analyzer so sad? Let's see if we can sort that out. Okay, so that shouldn't be running anymore. Let's see if that sorts that out. So hooks, spacing hook, we're going to add our layout hook down here. So layout hook, a spacing hook, and this has got inner px, which we said was going to be 5, outer px, which is also going to be 5, and then what did I call them? Just top and bottom. Okay, top px, we're going to say is 0. We're going to move our status bar down to the bottom. And bottom px, we're going to say is what's that? Oh, bar height is what that needs to be, doesn't it? We need to save the space for the status bar. And then here we'll have our layout hook, and that's going to be some layout hook. Now, what we need to add in here is one of those trait objects that we spoke about last time with the key handlers. So if you look with the startup hook, we had that boxed method, and that if you think back to how the key bindings worked, where we had that boxed din trait object, we need to do the same thing here. So actually, this one, since we're constructing it explicitly, we need to put inside of a box ourselves. So we need to go and store that off on the heap so that it works correctly. Hey, good, Rust Analyzer is happy now. Cool. So we've got our startup hook, which is going to spawn a script. We've got our layout hook, which is going to give us some spacing. And the last thing we need to do is, previous time we added this reserve top as a layout transformer to save some space at the top of the screen. We don't need that anymore. If we leave that in, we're going to end up with kind of extra padding. So let's get rid of that. And then we won't need that reserve top either. Cool. So that should be us for adding our hooks. We've got startup hook, which is going to run our script. We've got layout hook, which is going to give us our spacing, and we've added both into our config. So if we go here and we do make build debug and sudo make install debug, this is something I added just because those release compile times were getting pretty long. So we're going to do a debug build just to speed this up so we can check things, but once we've finished, we're going to do a release build before we actually use that. See, way faster. There we go, cool. So that's all set up. So now if we use our restart key binding that we set up last time, we should see that the status bar jumps from the top down to the bottom, and we get some nice gaps around our window. There we go. Oh, we didn't get the status bar down at the bottom. Why didn't we get the status bar down at the bottom? Oh, because we didn't tell the status bar to go down to the bottom of the screen. That would be helpful. Okay, so let's sort that. So the status bar still says it's on the top. You should be on the bottom now. Cool. So yeah. Well, that's actually quite good. Now we've got the gaps, you can see it doesn't completely cover it, but this is why we've got that, why we're reserving that space, because otherwise the layout algorithm doesn't know about the status bar and it just goes on top of it. But if we say position bottom, and then we rebuild again, this time when we restart, it should correctly jump down to the bottom of the screen in the lovely space that we have available for it. So let's try that. There we go. Cool. Status bar down at the bottom of the screen. Lovely. Okay. So what else was in my to-do list? Oh, we were going to add a manage hook. That was the last one we were going to do. I think we'll do that. And then I said we were going to have a look at refresh and event hooks in the status bar, but maybe let's have a look at the status bar next time, because I think we're running quite late. We're not late, long, I suppose. We're already over half an hour. So a manage hook there's a couple of different ways of setting those ones up. And the thing that we're going to have a look at is a little helper which lets you use what's called a query and a manage hook together. So if you just register a manage hook, it will run for every single window that comes through. You can use queries to say that you only want a manage hook to run for a window that matches that query. So it's just a little helper. So rather than you have to write your own explicit code for going and checking properties about the window, they're kind of canned queries about window properties. You can go and have a look. So we're going to have this set workspace. So if we go to, oh, I probably should have double checked what that was. Extensions, hooks, manage. So extensions, hooks, manage, and we're going to have set workspace. I think that's what it was called. Extensions, hooks, manage, set workspace. Yeah. Rust analyzer is all set again. I'm not. Oh, there we go. Cool. And then the other thing we're going to need is we're going to need a query. So if you have a look on the implementations here, this has got an implementation for this pair of things, Q and H, where Q is a query and H is a manage hook. So we've got our manage hook that's going to set the workspace, and a query is something which can be given a window and go and tell you whether that property is true or not. So we are going to use class name, I think is what we're going to use. So that comes from Penrose X query class name. So we'll import that, and then I'll show you what that's doing. So do we have X in here at all yet? I don't, we do. So X query class name. Cool. So this lets us work with what's called the class name of a window. We need to get that for our window, for our browser. So I'm going to do it with this, which is Qtile. So if I open a new terminal and I use, let's make the font a bit bigger. If I use a program called xprop, then I can click on the window and it will dump out a bunch of information for me, which is useful stuff for writing these kinds of bits of code. So what we want to look for is something that says WM class. Here we go. And if we have a look at the docs on query, this is a query for fetching a Windows class name, and this is the second string returned under the WM class property. So this says WM class, and there's two strings here. Both of them say Qt browser. Sometimes that's different. So sometimes the casing's different, or sometimes it's a completely different thing. So you need to be careful with that. What you want if you're using class name is the second one. There's another query called app name, which is the first one, if you want to do that. So let's get rid of that terminal just now. And we'll go back to our code. And then here we need to make our manage hook. So our manage hook is going to be a box new, because we need to be boxed, and it's going to be this tuple of two things. So we're going to have our class name, which was Qt browser, I believe. And then we're going to have our hook, which is set workspace, and we're going to set it on, well, Qt browser is currently on workspace 3. So let's try setting this to workspace 5, and then that should mean that when we restart, you should see that this highlighted 3 down here should jump to 5. And that means that our hook has run and it's moved, even though we knew where Qt browser was and it was on workspace 3, we're going to shift it to workspace 5. So if we go here and we say manage hook, and that's going to be some manage hook, and we'll get that saved. Cool. Let's just have a little bit of space so we've got all our hooks together. So we've got our startup hook, our layout hook, and our manage hook. And just because it looks nicer, we'll do that. Nice. Cool. So that looks pretty much like what we need. We haven't got any unused stuff, so we've not missed anything. Cool. So we'll do our rebuild. And what we should see is that when we start, this should move Qt Browser to workspace 5. And so if we go to workspace 3, if I focus the right screen, if we go to workspace 3, there's nothing there. And if you go to workspace 5, that's where our browser is. So that's run correctly and move that over. But the other thing we can do is we can say, okay, well, let's move that back to workspace 3. So now we're on workspace 3. If we try and open a new instance of Qt Browser, that should automatically open on workspace 5 for us. So anytime the new window opens, we're going to move it and run the manage hook. But that doesn't mean that you can't then move the workspace away from there. So if you had a look, we can move that away. You can move that onto workspace 6 or 7, for example, and then get rid of it. It doesn't mean that we can't then interact with that window or do anything with it. All it means is that we will automatically move that to that workspace when it first shows up. And becomes managed by the window manager. And then obviously when we restart Penrose, it will run that hook as well. So it will kind of force it over onto that workspace when we first manage it. Cool. Okay, so there was a couple more hooks that we said that were possible. There was the event hook and the refresh hook. We're already running quite late on this one, so rather than look at those just now, I think we'll look at those next time as part of looking at what are called state extensions and the status bar, which is kind of how the status bar works. But also next time around, we'll add the named scratch pads, which is kind of like a sort of pop-up window that you can kind of provide. I'm missing those quite a lot. I make heavy use of those. So they'll be nice to have back. But yeah. For now, we've had a look at those different kind of hook points. We can kind of see how those work, and we've set up a startup hook, a manage hook, and a layout hook. Nice. Cool. So thank you for following along, and I'll see you next time for having a look at state extensions and the status bar. Later.